quite often ask, particularly if you're a management position, are you in control? Oh, yeah. Look, that's what I kind of think of the chance. Those serendipitous encounters.
It's interesting you mentioned the spectrum.
Well, every modern mobile phone is more powerful than what brought people to the moon.
A very good morning, good afternoon, good evening, and welcome to the Stream podcast, an unscripted, unedited, free-flowing conversation featuring guests who reject the status quo with a bias for action in the world of water and beyond. My name is Tom Freyberg. I'm an environmental journalist and content creator specializing in water.
And I'm Will Sarney, a water strategy advisor, doing my part to solve wicked water problems.
And today, to help kickstart the second episode for season 7, which focuses on legends, people who have made a serious impact during their fruitful careers in the world of water, we are absolutely honoured to welcome Professor Dragan Savić, who is tuning in from Exeter today. And before we hand over to Dragan, we'd also like to thank our charity partner, Frank Water, and also our sponsor, Raymond James. So, Dragan, thank you so much for joining us. I know when me and Will were sort of brainstorming and coming up with ideas of who would be considered a legend, you were definitely one of the first names for the impact you've had in the world of digital, in hydroinformatics, in lots of different areas we'll talk about today. So yeah, thanks for joining us.
Thank you, Tom. Thank you, Will. I hope the legend doesn't just only refer to my age, but I'm glad to be here. Thank you for inviting me.
That's a good point, Dragan. No, it has nothing to do with your age, longevity, any of that. Wisdom, yes, but not age.
So Dragan, we know this conversation could go many different ways. As we always say, it's quite unscripted. But I think we've heard you talk a lot on kind of digital strategy and AI and hydroinformatics, and we'll get into that. But I think personally, what I would love to hear on this podcast is your kind of origin story, if you like, from getting a master's in Belgrade, and then there was some time spent in Canada, and then coming back to the University of Exeter, where I'm a proud graduate, and great to hear you're tuning in from Exeter today as well. So, but actually your sort of historic origin story and kind of how you ended up where you did. It'd be great to get a bit of flavor on that to start with.
Yeah, thanks, Tom. How much time do you have?
Just keep going.
Hours.
We're rolling.
Hours.
Yeah, we're rolling.
Yeah, no worries.
Yeah. Well, I would like to take the credit for what happened in my life. I think most of it was highly influenced by chance. And I was born and raised in Belgrade, what used to be Yugoslavia. And I wanted to do some kind of engineering, but in the summer before going to university, I was going to be a pilot. I was going to be electrical engineer, but I ended up going to civil engineering because most of my classmates at high school went to civil engineering. So it gives you an idea, how very little I knew about what the life could look like and what the professions could look like. So I went into engineering, and again, I thought I'll do bridge engineering or buildings or roads. Water wasn't kind of on the horizon. And then in the second year, we had a brilliant professor of fluid mechanics called George Haydn, and he was absolutely brilliant. So after that, I decided I'm going to do water. So my undergraduate studies were 5 years long. That's how long it lasts in Belgrade. And then after that, I started working as a consultant for a large state-owned company, Energo project. And then after that, I was enrolled into a master's course at last 2 years. And I say I was enrolled because at that time I had to do national service. And while I was doing national service, my best friend enrolled me in this course, although I thought I will never cross, the threshold of the university again. And because we worked for the same company, we studied together, kind of, revising together and everything. So he did enroll me in the master's, but master's was part-time. So I was working 8 hours a day. And then afternoon, I would attend lectures at the university from 4 to 8 or something like that. And I remember my girlfriend at the time, she said, "That's it. I don't see you. You're tired during the week. The weekend you revise. So we either get married or separate." So we ended up getting married. But by the by, that was when I decided, if I ever do a PhD, it will be full time. I'm not going to do this, work and studying. So that's how I ended up in Canada.
So Dragan, I didn't know that about, well, two things. One is that your girlfriend, now wife, I assume, basically laid it out for you in terms of path forward. I find that interesting and amusing. But I did the same thing that you did, where I was working during the day and getting my master's degree at night. And I would travel on business and take my dissertation with me and work at it, early in the morning or mostly at night after working. Yeah, it was rather sobering. I don't recommend it for anybody. And it took me a long time. And I was working for Garrity and Miller, which is a groundwater consulting firm in the US. But there are advantages to it, just having the ability to work and also do the academic work. I think it really does shape your thinking about the profession. So, yeah, interesting.
Yeah. And you're absolutely right, because I think what we are going to talk about is how a chance shapes your life and your choices. And in this case, when I came back from that national service, which I didn't like very much, I can tell you, but that's another story. A new guy came to the company, the consultancy that I used to work for, and he got his PhD from the States. He was very flamboyant, interesting stuff he was talking about. And at that time, this was 1984, the first desktop PCs have started to emerge. If you remember IBM XT and AT, they're really, it's really funny when we think about those days with memory on 640K and DOS could access only 512. Unbelievable. And anyway, we started looking into writing some software, which was, wow, for that period, really amazing. Because I was into that area before. When I was at the university, I used to own Sinclair Spectrum. And I don't know whether you in the States knew about it, but in the UK, it was a big thing. And in Europe. It was a programmable little computer, which is just a keyboard, and you connect it to your TV and also to your little Sony tape cassette.
Wow.
So you load programs from the tape cassette. Anyway, because I was kind of young and interested in that stuff, I got into programming some of it on those computers. And I know the older engineers were looking skeptically at us. And I've heard stories saying, "Oh, the boys are playing again." So yeah, it was an interesting time, and that chance, I met that gentleman. He was Professor Simonovic, who became my supervisor in Canada. He moved back to North America. He invited me to come and do PhD with him, and that's how I ended up doing it there.
It's so interesting, Dragan, when you mentioned about the spectrum, because my uncle used to work at IBM. I was born in '84, but my first ever computer, well, he brought it over, was the ZX Spectrum keyboard, which you would cable into an old box TV, plus my father's old cassette player, and you'd have to load up a software program with, I remember the command, load dash dash load. You would set the tape recorder off to load the program, go away and play football in the garden with my brother, and just pray to the God that when you came back, it hadn't crashed. And you had the program. And that was my first ever kind of computer. Well, we used, me and my brother naturally turned it into a games console and loaded games. But I remember it really well. And to think how far that's evolved over kind of 40 years almost to where we are today with well, computer power, as you mentioned, and memory and everything. But yeah, it's interesting you mentioned the Spectrum.
Well, every modern mobile phone is more powerful than what brought people to the moon. You know, that computer was very, very small, very rudimentary.
Yeah, that's pretty amazing. You know, when I was an undergrad, I took a programming class, you know, with punch cards. And boy, I found that to be painful, you know, because as you know, like one mistake and like nothing ran. And I was not really a great typer. So, you know, it was a handicap. You know, Brian, you bring up the word chance a lot. And I find that to be a really, really fascinating piece of how you, or a fascinating word to use when you talk about the arc of your professional career. And, you know, as we think about, you know, you as a legend and everything that you've done, this notion, this view of chance, I believe is incredibly valuable to people starting their career and really trying to map out, you know, where they might want to go or not go. Can you talk a little bit more about chance and how much you value that? I mean, it's pretty clear that you've done good with it, with this chance thing. And I think it's just invaluable advice to young professionals.
Yeah, I view chance from various kind of positions, both personally and professionally. And although I'm not a philosopher, I would even say philosophically, we need to look into it because chance introduces that element of unpredictability. You know, you can kind of plan your life path, and I can guarantee you it's not going to happen. Or, you know, if you're running a research project, if you're managing or doing a research project, again, the way you wrote the proposal and, you know, reviewers loved it and the funding agency decided it's worth of funding, the outcome is going to be different. And why? Because it involves humans. You know, I may have come up with an idea, I employ somebody to do it with me, and they come with their own ideas. They build themselves into it. So I think that element of predictability in our existence reminds us that we are not entirely in control. And I think that that's where I stop with philosophy. But it's important to say, people quite often ask, particularly if you're a management position, are you in control? Oh, yeah. Look, that's what I kind of think of the chance. You know, those serendipitous encounters.
Right.
In my first year at Exeter as a postdoc, young postdoc with young family, I arrived in January of '94. In April of '94, my supervisor sends me to Edinburgh, all the way on the train. Don't try it yourself. But it's kind of 8 hours journey. And there I met people who again shaped the direction of my work. I met there Professor Angus Simpson from Adelaide in Australia, extremely generous, open person who shared ideas, who shared the work that they've done there. And that gave me another kind of direction at that time. So I went into another kind of area of AI. While I was in Canada, by the way, 1987, I started a PhD. And in the first year, you're asked to do subjects or modules or courses in another department, auxiliary department. Yes, you do it in your civil engineering and water engineering, so hydrology, water resources, systems. But I was asked to choose something that will fit into my PhD. And again, lots of my colleagues went into the management department because we were doing modeling and optimization, and that's what they do in management. But I was thinking, I looked into what they were doing in computer science. And, you know, in the 80s, computer science was kind of just starting to appear. And I chose AI, artificial intelligence. And again, that was very serendipitous for my career, because from that time on, my work in the water sector was kind of intertwined with artificial intelligence. So going back to Angus Simpson, he came with his genetic algorithms. My supervisor was talking about genetic algorithms, and that's like a methodology that uses the analogy with genetic material and how you use that in optimizing water systems. And from those two, Godfrey Walters, my supervisor at Exeter, and Angus Simpson, kind of I shaped the entire career after that. And again, if somebody tells you, oh yeah, but it's you who's done it. But without that, I think my professional life may have taken a different direction.
Do you think, because you mentioned there about kind of getting philosophical about chance, but I'm convinced there is an element of serendipity, of coincidence, but actually I think there's an element that you engineer your own, because you refer to it as chance encounters, right? So you had to put yourself in those positions and those situations to meet those individuals, to have those conversations to then lead to that fork in the road. And I'm convinced there is a mindset and a certain optimism and being open to change and adventure where you can stack the deck a little bit in your favor of chance. I think if you're, I'm convinced of that without kind of getting into too much philosophy about, you know, is a coincidence really a coincidence? But I'm convinced you can stack the deck in your favor by being open, by being optimistic, by engaging in conversations that perhaps others are not open to, and that then favors you to have those chance encounters.
Yeah, I completely agree with that. I you know, and I was gonna, I agree with you, Tom. And Dragan, you have the quality of being open. And just, you know, looking at the landscape of what comes up. And I agree with you, Tom. It's the more you are open and, you know, put yourself out there, the more it favors chance. And you can pick, you know, and if you're so narrow that you don't get on the train and go to Edinburgh, then, you know, you're not going to have all those chances. So I think it's a really magical quality, really magical. And I really think all that you talk about it.
I think all that randomness, uncertainty in our lives and profession can be both thrilling and daunting. So if you take that thrilling sensation and then you kind of jump into it, you can do something. If you kind of, because it's daunting, you freeze like a rabbit in, you know, headlights, then those chances will pass by you. But that's, you know, my view, and I'm sure I passed few.
So, you know, this also ties into fear. And we're not going to talk about water anymore. We're going to talk about philosophy and life, I think, going forward. But I've got a rowing friend, and I was in a boat with her, and she said, life is too short to be afraid. And, you know, that to me ties into chance and, you know, opportunity and being open. And, you know, it's a richer life that way.
Well, that's how we experience that growth and discovery, I think, if we take some of the chances.
Do you think, because it comes back to, I remember when I made the decision to sort of found Atlantean, and I think we are programmed as people to maybe potentially take the pessimistic view and look at risk, right? You think in the way we're conditioned of risk favors the brave, but actually, and I think a friend once phrased it to me, and he's very successful in, he scaled a CrossFit franchise business and doing very well, but he said to me, instead of thinking and defaulting to what could go wrong, flip it and think what could go right. And it was at that moment where I thought, oh yeah, I hadn't really thought about that. So then went on to found Atlantean and, you know, that sort of thing. But it was quite interesting because at the time, the default is to think, oh my God, if I don't do this, and then I can't pay the mortgage, and then my family will be out on the streets. But I think, yeah, gentlemen, we're getting quite deep and philosophical here. Away from water. But do you kind of understand what I'm saying? It's like, it's coming at things and looking at them optimistically. It can, I think, change. But I think when we look at chance, we also look at luck. And I think, Dragan, you've worked so incredibly hard over your life, and you did take that 8-hour train journey, which I've done, by the way, with multiple changes, right? And some people could say, oh, you've been quite lucky, but actually you put yourself in a position where you've had those chance encounters and you said yes to, and it's the iceberg analogy where people only perhaps see the tip of the iceberg, not everything under the water that's got into those key moments, right? So, but yeah, maybe I want to talk about hydroinformatics because I know you've touched upon it, but effectively talk us through kind of because I know we're billing this as almost the godfather of hydroinformatics, right? As someone who's spearheaded that whole new area of that intersection between water, data, and information, right? So maybe talk us through kind of that role within Exeter and kind of how that's kind of led the way, really.
Yes, I was aware that Professor Mike Abbott, and an English gentleman who worked in the Netherlands at IHE Water Institute, he was the one who coined it in his book of 1990 or 1991, I can't remember now. And he was the one who was talking about 4 generations of hydroinformatics and how it developed over time from numerical models to what he called decision support systems, better visualization, decision making, and so on. So the godfather is actually Mike Abbott.
Okay.
But I was lucky enough to cross paths with him and quite a few other people, including colleagues from IHE Delft, from DHI, Danish Hydraulic Institute, and so on. And by coming to Exeter, I kind of plunged into that area wholeheartedly. I met quite a few people in the first few years. So 94 was when I moved there. 98 was a pivotal year for me when I went to the first hydroinformatics conference. The first one was, I think, in 94, but don't quote me on that, or maybe 96. So I went in 98, and this is where I met Professor Roger Faulkner from England, Vladan Babovic, who is now in Singapore, all stalwarts of hydroinformatics, various areas of it. And at that time, I wasn't a full professor. I was, I think, senior lecturer at the time, but lots of activities. And I thought, if I ever become a professor, mine is going to be hydroinformatics. But that was risky. That was very risky because nobody was called professor of hydroinformatics at that time, apart from the person who inherited the title from Mike Abbott at IHE. I will remember later on. Sorry, at the moment I lost his name, and I apologize in advance to him. That was the time when I decided to do that. But again, it was risky because the safe way would be professor of water systems, professor of water engineering, hydraulic engineering. That's the traditional kind of names for people with my background. But I haven't regretted it for a moment, and I still proudly carry that title.
You have a lot to be proud of. So the arc of starting there with hydroinformatics to the feeding frenzy we have right now around AI. Can you talk a little bit about that and, comment on, the feeding frenzy around AI and,
Yeah.
maybe the good, the bad, and the ugly?
Yeah, the key here is that in parallel with all the research activities, there is proliferation of very powerful technology, and I'm talking about computing and communication technologies. So, nowadays we're able to sense almost everything. The number of sensors, the amount of data. You've heard that famous that the 90% of the data generated today has been generated in the last 2 years. It's the exponential growth of amount of information. Just imagine, how this proliferation of technology has caused changes in businesses. The demise of, I don't know, Blockbuster video renting in comparison to Netflix and all those Disney Pluses and whatever happened. So it's not just kind of proliferation of some kind of methodologies, AI and everything, but it is being powered by this change in technology. But let me go back to AI. AI is not something that we invented in the 90s or 2000s. It's been around for a long time, but without this technology, it was difficult to move from that theoretical to some practical applications. So one of the first things that I was doing, for example, was to do rainfall runoff modeling using neural networks and something called genetic programming. So linking the rainfall to what it actually flows in our rivers, and where we can then predict how much water can be abstracted for water supply or for irrigation, is the basic tasks in water engineering. And up to that point, people were using something called conceptual models, set of reservoirs that water flows from one to the other, and then you get what is flowing in the end. But when we started using neural networks, which are kind of black box models of how our brain, or very simplified models of how our brain works, we managed to get even better accuracy than classical models. And then with genetic programming, we managed to open a little bit that black box. So that's just one of the examples of very simple applications that we started within late 80s and early 90s. And then that changed 2 years ago, or is it not even 2 years ago, when large language models, ChatGPT, came into existence, and now everybody is doing it. Everybody is using it, and the powerful tools are at the fingertips of average Joe Blog these days, like myself, rather than having to have all that machinery and the knowledge of everything that it works. So I think the beauty of it is that we do not need to know anymore how it works, because it works. On the other hand, I'm quite conscious that we may be overselling what AI can do, and people like to kind of fantasize and say, "Oh, they're going to take over. Oh, we will be responding to machines, or we will be ruled by the machines." But I don't see that. And that goes back again for what Tom says about being optimistic. I've always been an optimist. I always think that in us humans, we have something good that we can actually avoid some of the biggest disasters for humanity rather than, for individuals or for individual countries.
I love that.
I think it's very a well-trodden sort of narrative path on AI is to be pessimistic, right? You mentioned the red-eyed T2000s running down the street and the robots taking over in our jobs, and it means we'd have no purpose. But I think there's such incredible potential for. Do you know what? I was listening to a podcast, not the stream, by the way, but another podcast.
There are other podcasts?
So I've heard, right?
Huh.
And it was a conversation with Brian Cox, and they're talking about the sort of exponentiality of AI and the growth, as you mentioned, with the technology dragon, and we're now at GPT-4 going to 5, and where the hell is this going? And actually, there was this really kind of great point where they said, say, for example, AI does take over in that narrative. Can it do a worse job than what we've done as humanity to the planet? Right, it's just this. No, but if you think about, like, there's geopolitical wars now going on around the world. We're fighting for resources. Think about the impacts of what we've done industrialization in terms of impact of carbon on climate change. All these things where if we look back and were to redo everything, could we have done it much better? And it's just this really interesting point. It said, okay, say AI takes over as managing resources, people across a country. Is it a bad thing that it could actually reorganize and do things properly as opposed to like learn from the past and our mistakes? It was the first time I heard it said. It was just interesting.
There is also the chance that, AI, whatever that becomes, just gets annoyed with us. Like we could just be an irritant to it. I mean,
right. Yeah.
Look, this optimism that I feel about everything, about the environment, climate change, wars, whatever. I just remind people how in the 80s we have the ozone layer hole. And that was something that we thought is going to kill us because the ozone layer will be destroyed and we won't be able to survive. And we found a solution. We found a different way of dealing with things. The only problem with humanity, I think, is that we have that big momentum. It takes the time to change, to move to a different track. But we are moving in the right direction with everything, and including, I think, climate change. And AI will play a role in that as well.
Right. Have you read anything by Peter Diamandis at all? He started Singularity University and launched X Prize, but he shares your point of view in terms of if you really look at the data, the information, it is a trend of improvement for the quality of life globally in exponential technologies, digital being one of them, and advances in material sciences are really having a very, very positive impact in terms of delivering better healthcare, better education, improving environmental conditions. I believe that being an optimist is based upon, a recognition that we're headed in the right direction, despite the, ongoing tragedies that we see in the world and, the profound challenges in dealing with climate change and water and, biodiversity and so on.
He's the author of Abundance, right? Diamandis. I've got the book on the shelf back. It's a great newsletter that he said. I'd highly recommend everyone subscribe because it's definitely an optimistic view of how AI can improve way beyond water. And I love his view on healthcare, right? And the ability to look at multiple data points and, for example, scans and pick up things that maybe the humans can't. So one thing you've spoken about before, Dragan, is this mega trend that we continually hear touted in different conferences about the impact of climate change and population growth on infrastructure and assets and cities. But I know we've spoken about it, but actually the reverse of that and the impact of population degrowth. And there's a great, I think from Japan you reference, or China as well, right? A great example of that, where you're baking in these 30-year project investment periods based on these numbers of population growth. But actually, from looking at the current data, the population is not actually going to reach that. So it'd be great to sort of get your views on that, and how you sort of see that playing.
Yeah, we're back to that issue of unpredictability. Everybody is looking for growth. And if you look, for example, in predictions from the 50s and 60s, we're looking into how the demand for everything, for materials and for water, is going to grow. And that's how we design in engineering. So we take a point in the future, like 30 years ahead. That's what master planning in water distribution system is. For example, you hire somebody to do a population study. You know how each person, on average, how much water they take in a day, and you calculate what our demand is going to be for the city, say London or New York, in 30 years ahead. And it's ridiculous. I mean, who can predict what can happen in 30 years' time? So what happened in Tokyo is the population went down. And with the population numbers going down, you get lower demand. With lower demand, you build your big system. So that means water flows slowly or slower through the pipe, stays longer. So it gets, water quality is a problem. If it stays longer, there is more chance that you will get some kind of intrusion, although Japanese networks are very solid and they have the lowest losses in the world when you think about it. But still, we don't want that water to sit too long in a network. The same happened, or similar thing happened with Eastern European countries when the communism stopped, or when at the end of the 80s. And because water was a social category, so they didn't used to pay for it. When they started paying for it, they started reducing their personal usage. And what happens again, over-designed systems would have a problem with water quality. So my point is, we cannot anymore look at these challenges like, I know what is going to happen in 20, 30 years' time. We have to adapt our solutions to that, what we call deep uncertainty that is not kind of something that we can calculate, that we experienced in the past, and then we can calculate the probability of something happening. So we should move towards adaptable solution that will satisfy many possible future scenarios.
So what are the examples of that in terms of building, infrastructure with the flexibility to address surging demand, but also declining demand, and, coupled with the impacts of climate change and, other factors? So, like, who's doing it well, Dragan?
Well, I have to take my hat off to the Dutch, because quite a lot of work comes from the Netherlands. I think people in the States, or at least researchers in the States, are addressing that problem. Patrick Reed at Cornell, for example, George Heraclis, quite a few of them are doing similar work in various areas in Australia. Holger Meyer, Meyerline, host note in the Netherlands. She is the proponent, or she started this idea of dynamic adaptive pathways, so that we develop pathways like for, 30, 50 years ahead, but we adapt them along the way when that deep uncertainty is kind of resolved when we know in 10 years' time what the real demand is, so that we can adapt our solution to that. So there are people doing that, and I've been doing that for some time, and recently, over the last 3 years, I've been doing that work through a European Research Council Synergy grant that gave 4 of us 10 million for 6 years to investigate how water distribution systems can transition into sustainable way over that deep uncertainty. And, you know, I have brilliant PIs on that, Marios Polikarpou from Cyprus, Barbara Hammer from Germany, and Phoebe Kunduri from Greece, from Athens. And they come from different kind of areas from mine. So I'm a water engineer, Barbara is a machine learning expert, Marios is a control engineer, and Phoebe is environmental economist. So together we're trying to have that holistic view of transitioning to sustainable water distribution systems.
Fascinating.
Yeah, it's super interesting to bring in those different disciplines together, right? As you mentioned, environmental economics to machine learning to hydroinformatics on your side as well. One of the things I was going to ask you, Dragan, is I'm a big fan of your work on, I was going to say Twitter, but now we have to call it X. And I know a lot of people are actually coming off of, go on, Will.
Blue Sky.
Do you know what? The call before this recording with the team, we actually had a conversation on Blue Sky. It's the original founder from Twitter, right? Has gone on to create a positive social media platform.
I just joined.
Yeah.
Cool. Yeah, we're gonna check it out. On your, I guess you're still on X, Dragan, until the Blue Sky exit the move. Yeah.
Look, I tried Mastodon when it was kind of starting, and it didn't catch on, and I couldn't understand all the things. X is still simple, but I will try the new one.
And one of your posts on I guess the platform that we'll move away from, but is you mentioned being at this. I think the phrasing was being at the sort of sunset of your career, of all the things you've done and achievements and citations. Is one of the most proudest moments was sort of mentoring up and coming young water professionals, right? So I'd love to sort of maybe towards the end of this podcast just get your insight on that and how perhaps you can reflect on those experiences and maybe how you want to do more of it for, say, young professionals and students tuning into the podcast as well.
Yeah. Look, I'm not saying I've achieved everything and, you know, I'm untouchable, but what I'm trying to say is I don't have any personal ambitions in that sense anymore. So I'm totally open here. So I can give everything to early careers or mid-careers colleagues. So I've been asked to help, to supervise, to support, to review, and I offer my services for free, whoever approaches me. And I repeat that often and often because lots of people are kind of, reticent. He is whatever he is. Or so this is a call for young professionals in this area of water, AR applications, hydroinformatics, to get in touch if I can be of any assistance. I appeared on Early Careers IWA webinars, and I'm doing that both through University of Exeter and through KWR Water Research Institute, where I'm a global advisor of data sciences. I still have 8 PhD students that I want to kind of propel through the system by the time I retire. And that gives me immense satisfaction working with these young, clever people. Are much more clever than I was. And because now everything is on them to take the mantle and do some of, or find some of these solutions that we're talking about. You know, how do we plan with this deeply uncertain environment, or how do we plan for long-term future? I was in China last week, and I know in the Netherlands we have about 120,000 kilometers of drinking water pipes. By the way, that's 3-4 times more than we have roads in the country. In Beijing only, they have 1.3 million kilometers of urban water pipes. You know, those pipes are aging. The cities are growing. So demand is not just predict how much water is going to be, but where is it going to be needed? Which part of the city is going to develop? There are parts of the city that are changing. You know, some parts are, as they call, gentrifying. Some parts are bringing new people in. The demand will change. So it may stay in absolute terms, but where is it going to happen? That is interesting. We were using mobile phones, you know, when people are moving through from cell to cell of the cellular network, as you call them, Will, in the States, we can actually calculate the number of people in the cell, and then we know what is the approximate demand at that time, which is completely different from the situation of 20 years ago when we were doing standard profile. We use that profile for every city in the UK when we want to model our system. And we thought we were clever because we use different profile for Saturday and Sunday. We know people get up later.
I love it.
Well, I think certainly, if, as you mentioned, people might be a bit reticent of coming forward to ask for your support and mentoring, but, you know, as part of the podcast, if we can help, you know, get the word out that you're more than happy to help, you know, we'd love to do that. So
can I just add one more thing, Tom, about what I'm trying to do? Look, they say if you take your job as a game, you will not work a day in your life. And that's where I am. I always enjoyed doing this research, but also focused on the applications. But I realized that I missed something in my life, and that is I haven't done much work in Africa, particularly sub-Saharan Africa.
Right.
And nowadays, I think that's where most needs are in providing safe drinking water and sanitation. And there are some social enterprises and people who are from that part of the world, and they feel that they need to put back something into. So I'm also trying to work with some of those, and I have to mention, I hope this is appropriate, an organization called Global Empowers, and it works in Zambia, and they want to create for 60 villages, 60 communities, access to water that they haven't had up until now. We're in the 21st century. This is still the time when people share the water sources with animals, with their domesticated animals. And a gentleman called James Mwasa, I think, runs this organization. And also, I would say the Salytics is doing great work with Walid Khoury, who is trying to empower women to deal with water issues, because they normally deal with water, but he's bringing a business model that will financially support them in that. And Global Empowers are also trying to empower local communities then to maintain and keep the things going. And he links it also to carbon savings. So to get the funding to those
Mm.
underprivileged and those who can get the water by themselves. So that's where I'm also putting some of my activities in.
Fascinating. I want to check it out. I agree with you. I think Africa has just, profound problems, but also there is an entrepreneurial community in Africa that we need to promote and nurture and engage with.
And looking into future, Will, I know that big proportion of the world will depopulate over the next few centuries. We're talking about Asia. Look what's happening with China, North America, Europe. Obviously, everybody's talking about aging population in Europe. But you know where the biggest baby boom is happening? It's Africa. So that's why we need to act now rather than wait and then cause again problems because of the basic necessities, individual rights, whatever you call it.
Right.
Yeah, and as kind of states go from developing to developed and progressing through the middle classes, the need for what comes with that in terms of improved lifestyles as well and impact on resources. Dragan, we need to unfortunately wrap up. I know we could have kept going for much longer, but it's been an absolute pleasure to sort of hear an alternate, as well as the leadership on hydroinformatics and digital and AI that you're used to talking about. But I think hearing the other side of your story as well, especially from kind of Belgrade to Canada to the UK. So yeah, thanks so much for joining us. Will, any final kind of comments and reflections from you?
Wonderful to have time with you. I look forward to seeing you at Aquatech, if not sooner. Your comments about chance and being open, profound personally for me. You just nailed it. And I think that's just such a great message, for life in general. So as far as I'm concerned, you are a philosopher, even though there are no degrees associated with that. So thank you for that perspective.
Thank you, Tom and Will, for inviting me. I enjoy this.
Good. That's what we want. Dragan, take care of yourself.
Thanks, Dragan. Thanks, guys.
Be well.